let's talk about the even, odd rule. So, the even, odd rule, because you're going to hear me say this a lot. Says, if I have a variable to an even power, so x squared, x to the 4th, x to the 6th, x to the 12th, x to the 18th, those are all even numbers, right? So let's say we have x to the 18th. And we write it under the square root. The square root is the 1/2. So 18 and 1/2 are both considered what? Even numbers, right? So even, the square root's even. What is 18 divided by 2? 9. So I get an odd exponent out, therefore I need absolute values. So if you have an even radical, an even exponent inside, but your answer outside is odd, you need absolute values. And I write even next to the radical because eventually in chapter 6 we get to like cube roots and 4th roots and 5th roots. So those become odds. So even, odd is kind of how I treat it. The even, odd rule. You go even, odd, you get absolute values. The reason for that is, what do you know about the square root of a negative number? Try to type it. Anybody have their calculators up? Type the square root of -5. Yeah, you can't do it, right?
Because it's imaginary.
Because it's imaginary. So here's the thing. If this is an even exponent inside, type the square root, put parentheses around -5, and square that.
5.
Yeah. So it comes out as the absolute value of 5, though. So if you treated the square root of -5 squared, and you said, oh, the square roots and this cancel, and you wrote -5, that's not the same. Put your absolute values on it, you get the 5. That's where the absolute value rule comes into play. Good morning, Mrs. McBride. Yes, she is. She must know because she already stood up before I even looked at her. Thank you. Bye.
Good luck.
Oh, do you have your
Yeah,
good luck? It's just the price.
okay, thanks. Can I do the back for bonus?
It's gross. Like really hard. You don't want to do it. Oh yeah, don't forget that. Okay, so as a general rule, basically all we're doing is dividing the exponents by 2. The remainder stays in the radical. We will only have a remainder if it's odd. So again, x to the 7th, this is odd. So what's 7 divided by 2? 3.5, right? So that 0.5 is kind of like that 1/2 power you're seeing here. So it's x cubed out, the 0.5 in. That makes sense? We're going to do more examples. Okay, so the very first example, we simply have the number 12. The square root of 12 gets broken down into what two numbers? 4 and 3. What is the square root of 4?
2.
Okay, and can we simplify the square root of 3? Nope. So this becomes the square root of 4 becomes the square root of 3. Square root of 4 becomes 2. So you get 2 square roots of 3. 48. What two numbers multiply to give me 48? Yeah, 6 and 8, but those aren't the best two numbers. They're okay numbers. There's even better.
2 and 24.
Remember, we're looking for a high perfect square. So you're looking for 16 and 3. The square root of 16 is about the square root of x to the 6th. Remember, our rule is take the exponent, divide it by 2. 6 divided by 2 is? Can't do anything with root 3. However, what happened here? Even became absolute values. Okay? Square root of 400.
20.
400 is a perfect square. Yep. Becomes 20. Square root of x squared becomes absolute value x. Even to odd. Okay, 20 is what two numbers? Square root of 4 becomes? Now, x to the 5th, this is odd, right? So we know for sure 1 stays underneath the square root. So you take 1 away, you get 4. 4 divided by 2 is? So that's 2x squared, square root 5x. Good? Not terrible, right? Just different. Okay, 48 we already said was what two perfect squares? And then you just look at different variables separately. So we're going to look at the squared, x squared, separate from the y to the 4th. So 16 becomes, x squared becomes, and 4 divided by 2 becomes y squared. The square root goes away for these variables because they're even. So that only leaves root 3 underneath. However, this was even and became, so you need absolute values. Okay, 8 is 4 and 2. Square root of 4 is 2. 25 divided by 2 is odd. So it's like 24 divided by 2, which is 12. So that means the 2 and an x stay underneath. Square root of 9 is 36 divided by 2. Even, no absolute values, guys. Okay, can I simplify the square root of 6?
Yes.
No. So it's going to stay underneath. The square root of x cubed, we bring 1 out. 1 stays under. 6 divided by 2 is, so you get y cubed. It gets absolute values by itself. 9 divided by 2 is 4, remainder 1. I'm sorry.